Hello, welcome to Organic Chemistry Lesson 2. Today we're going to be looking at the structures of two types of hydrocarbons, the alkanes and the alkenes. To get started, I'd like you to answer the following three questions. What elements are present in hydrocarbons? What are the three types of fossil fuels? And why is crude oil described as non-renewable? Once you've jotted those answers down, put them to the side and we'll look at them again at the end of the session. Okay, so we're going to jump straight away into our first task. Can you answer these true or false? 1. Crude oil is useless. 2. Coal is formed from plankton which fell to the bottom of the sea. 3. Plastics come from crude oil. 4. Natural gas was formed from tree and plant material. 5. Crude oil is green. 6. Crude oil has to be separated out into its fractions by fractional distillation. 7. Coal and natural gas are formed together from the same organic material. And 8, we get aeroplane fuel from crude oil. Okay, let's go through the answers. 1. Crude oil is useless. Yes, that is true. It's only useful when it gets turned into fractions or separated out into its fractions. Question 2. Coal is formed from plankton which fell to the bottom of the sea. That is false. That is crude oil. 3. Plastics come from crude oil. That is true. 4. Natural gas was formed from tree and plant material. That is false. Coal is formed from tree and plant material. 5. Crude oil is green. False. It's a sticky blackish brownish liquid. 6. Crude oil has to be separated out into its fractions by fractional distillation. True, if you want it to be useful, which we do. 7. Coal and natural gas are formed together from the same organic material. It is false. Natural gas and crude oil are formed together from the same organic material. And finally, 8, we get aeroplane fuel from crude oil. That is true. So, before we look at alkanes and alkenes on the next slide, I want to go over a couple of keywords that are going to appear a lot in the rest of this lesson and subsequent lessons. The first one is hydrocarbon, a compound found in crude oil which only contains hydrogen and carbon atoms. Hydrocarbons are covalently bonded molecules because they only contain non-metal atoms. The second word is homologous series, which is a group of compounds with similar properties and the same functional group. Chemicals in a homologous series increase in size by one atom as you go up the sequence, which you will see clearly in the next couple of slides. The third words are functional group. A functional group is a feature of a molecule that gives it certain properties. For example, all alcohols contain an OH or hydroxide group, and all alkenes have a double bond. The next word is alkane. This is an homologous series of hydrocarbons that are found in crude oil. We'll be looking at the structure of these in the next slide. Thank you. Okay, so let's have a look at the structure of alkanes. Now, you will be expected to be able to draw all of the alkanes up to the alkane with 10 carbons, which is known as decane. So for now, we're just going to concentrate on the first 6. So the smallest and simplest alkane is called methane. Its chemical formula is CH4, and you can see it's got a single carbon atom and it has 4 hydrogen bonds coming off it. Now, those bonds are covalently bonded and it is a single bond. Then the next alkane is ethane. Its chemical formula is C2H6. As you can see, we've got 1 carbon here with 3 hydrogens coming off it, all as single bonds, but then it has a bond to another carbon which also has 3 hydrogen bonds coming off it. Now, what we should be able to see from those two, methane and ethane, is that each carbon should have 4 bonds coming off it. And if you remember what a covalent bond is, it's where the electrons are shared. So to make sure when you're drawing these correctly, every carbon atom should have 4 lines coming off it. Hydrogen, because it only has 1 electron with which to share, should only have 1 line coming off it. So if we look at this hydrogen here, it's got 1 line going to the carbon, and if we look at that carbon atom in isolation from the other one, we can see there's 1, 2, 3, 4 lines coming off it. Propane follows the same pattern. So there are 3 carbon atoms and each carbon has 4 lines coming off it. Butane, C4H10 means it has 4 carbon atoms and 10 hydrogen atoms. Pentane, C5H12, has 5 carbon atoms and 12 hydrogen atoms. Finally, there's hexane, which is C6H14. So there are 6 carbon atoms in a chain with 14 hydrogen atoms coming off it. Now, because they increase by 1 carbon atom every time and 2 hydrogen every time, it is fairly straightforward to predict, if you know the number of carbons, how many hydrogen atoms they will need. So you can calculate the formula. On the next slide, I'll be showing you the general formula for the alkanes. So you could calculate the number of hydrogen atoms an alkane with 100 carbons would have. And we'll have a look at that in the next slide. Okay, so here it is. The general formula for alkanes is CnH2n plus 2. So if you substitute n for any number, let's say 100, you had 100 carbons, your number of hydrogen atoms would be 2 times n, so 2 times 100, 200 plus 2. So the formula for an alkane with 100 carbon atoms would be C100H202. Okay, now we're going to move on to the alkenes, and this is where it starts to get a little bit more complicated. The alkenes are different from the alkanes because they have something called a double bond. So this is where, in a covalent bond, 2 electrons are shared from each atom. So the smallest alkene is ethene. Its formula is C2H4. So there is a C, which has 2 hydrogens coming off it, so that's 2 of the 4 bonds for that carbon, and then it has a double bond to the next carbon, which has another 2 hydrogen bonds coming off it. So if you look at each carbon atom in isolation, they each have 4 lines coming off it, 4 bonds. 2 of those bonds are taken up in the double bond. And it is important to remember that the double bond can only happen between the carbon atoms. Because hydrogen only has 1 electron to share, it can only form single covalent bonds. It cannot form double covalent bonds. So alkenes increase in size by 1 carbon atom, the same as the alkanes do. So propene is C3H6. So we have a C double bond and then C single bond C, with hydrogen coming off the C's at regular intervals. Now, if you look at each carbon atom in isolation, they should all have 4 lines coming off it. So the first carbon, 1H there, 1H there, 2 lines for a double bond, that's 4 bonds. With the next C, it's got 2 lines attached to the first carbon, 1 single bond to an H and 1 single bond to the next carbon, so it has 4 in total. A common mistake is to put another hydrogen onto that carbon. Okay, so always make sure to count. There should be 4 lines representing 4 bonds coming off each carbon atom. The next alkene is butene, C4H8. Again, this has 4 carbons, and there is 1 double bond between 2 of those carbons. And if we check again, every carbon has 4 bonds coming off it. Pentene is C5H10. So again, 5 carbon atoms with a double bond between 2 of those carbons. And the final one we're going to look at today is hexene, C6H12. Just 6 carbon atoms with a double bond between 2 of those. Okay, so here is the general formula for alkenes, CnH2n. So if we substitute any number for n, let's say it's 100 again, so it would be an alkene with 100 carbons would be C100H200. Okay, so time for some more keywords. There is saturated and unsaturated. So saturated means full up. There can be nothing more taken in. So alkanes are described as saturated because no other atoms can be added. Basically, it means there's no double bonds. Alkenes are unsaturated. They are not full up. And this is because they have double bonds. Double bonds can break open leaving a single bond between the two carbon atoms, but then each carbon can then take on another hydrogen. Okay, so to test for the difference, you would add bromine water to an alkene. Now, bromine water is kind of an orangey brown liquid, but in the presence of alkene, it reacts with alkenes and it turns colourless. If you put bromine water with alkanes, which are saturated and cannot open up, that don't have any double bonds, there is no change, so it will remain orangey brown. Okay, so that's an important test to remember. You need to know the test, bromine water, and you need to know the colour change. So in the presence of alkenes, bromine water turns from orangey brown to colourless. Okay, so here are your tasks on alkanes and alkenes. The first task to complete is to watch the video on this link and make some notes. Secondly, I would like you to complete the worksheets on alkanes and alkenes. Then finally, I would like you to go back through this slide and write down all of these new keywords that we've discussed. So homologous series, functional group, alkanes, alkenes, saturated, unsaturated. Write out their definitions and learn those. So look, cover, write out, repeat, check. Thank you. At the start of this lesson, I asked you 3 questions. Let's have a look at these and go through the answers. Okay, so question 1 was what elements are present in hydrocarbons? It's hydrogen and carbon. Question 2, what are the 3 types of fossil fuels? It was coal, crude oil and natural gas. Question 3, why is crude oil described as being non-renewable? It is being used up at a faster rate than it is being made, so it will run out eventually. Now, can you head over to Educake to test yourself on what you have learned? Thank you so much for listening.